All right, so I'm actually going to skip by E for the time being and come back to it. So these videos might be in a little bit of a different order than the actual example pictures. So the reason I want to do F first is because it's the sweet spot of intersection of three planes. This is, even though one of the 8 is not any better or worse than any of the other of the 8, this is the one that is most typical, even though there's a 1 in 8 chance of everything happening. And this is where three planes meet in a single point of intersection. I do want to say that if you take a look at these three planes, as in the equations of these three planes, you'll notice that they're normals. I'm going to underline stuff right here. They're normals, this part of it. And yes, I know the D is on the other side, not that it matters. What matters is that it is consistently either on the left or on the right. But if I take a look at the normals for each of these three planes, there isn't any of the patterns that happened in the previous 4 examples that I did. So in A, every one of them kind of reduced down to the fact that they were all 3 the same plane. And if all 3 are the same plane, that means they intersect in the plane, and you had to name that. In the second case, 2 out of 3 had the same normals. The D was not. That meant you had 2 parallel and distinct planes, and the other one ran through it, but all 3 planes didn't meet anywhere. But there was a pattern to be found. In C, there was a pattern to be found. The normals were all scalar multiples. The D's were not. That meant all 3 of them were like this, stacked, but space in between. So there was no meeting point or meeting line or meeting at all of these 3 planes. Again, pattern. And then this one, 2 of the 3 were identical and the third was not. So again, you had no intersection. If you take a look at this particular set of normals, there is absolutely no pattern whatsoever. And when there's no pattern whatsoever, you have to do this little pre-test. So I'm going to do it up here, and we've seen it before, and I'm just going to make a little note that the normals have no pattern. So step 1 is calculating something that we've done before, the triple scalar product. So I'm going to do the calculation for the triple scalar product here, and then I'll come back to what it means and why we're doing it. So the triple scalar product is taking any of the 3 normals, any 2 of the 3 normals, and crossing it, and then when you get that result, you dot it. So it doesn't matter which of the 3. I'm going to stick with this every single time we have no pattern. So first thing I'm going to do, and I don't know if this is movable. Nope, would not make any sense to make it movable. Of course, that doesn't help. I'm going to pause, fix this stuff, come back. Okay, so moved all my stuff and set up for the cross product of normal 1 digits and normal 2 digits. Those digits better known as components. So I am going to scribble, 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 down to the right, minus down to the left, down to the right, minus down to the left, down to the right, minus down to the left. So I end up having to take -4, 8, -4, which is the result of the cross product, and I have to dot it with the normal that I didn't use, which is 255. So negative 4 times 2 is negative 8, plus 8 times 5 is 40, plus negative 4 times 5 is negative 20. And what you are looking for is the result of this. And if it ends up not being 0, we have a point of intersection. So negative 28 plus 40 is 12. 12 is not 0. That means we have a point of intersection. We will get into what happens when it's actually 0, but not equal to 0 means point of intersection. So now I get to show you how to find the point of intersection now that I've proved there's going to be a point of intersection. And again, the only reason I did any of this calculation was because the normals had no pattern. Out of all three of them, there was no pattern whatsoever. So I'm going to do this in blue pen, maybe a little bit of green. So x plus 2y plus 3z equals 6. 3x plus 2y plus z equals 9. And 2x plus 5y plus 5z is equal to 14. Now, as I said, it doesn't matter where the d is as long as the d is consistent. So you can either have it on the left equaling 0 consistently, or you can have it on the right equaling the d. So it doesn't matter one bit. And our first step is to do elimination, like way back in grade 10. Only we want to eliminate the same letter twice. Okay, so that means we have to decide, do we want to eliminate the x twice, or do we want to eliminate the y twice, or do we want to eliminate the z twice? And the actual answer to that is it doesn't matter one bit. So I am going to pick the x, because the numbers, I don't know, I like the number 6. So I'm going to times this one by 6 to make a 6. I'm going to times this one by 2 to make a 6, and I'm going to times this one by 3 to make a 6. Now you have to be careful, because when you decide to make the 6, all the other numbers change. So you're doing the scalar multiple of the whole thing. So 6 times x, 6 times 2y, 6 times 3z, and finally 6 times 6. 2 times 3x, 2 times 2y, 2 times z, and 2 times 9. And 3 times 2, 3 times 5, 3 times 5 again, and 3 times 14. And now you tell me what you're going to do as far as elimination goes. So I, for fun, and only because I've got them right above each other, I'm going to take 4 minus 5, and that way I won't have to jump. And then I'm also going to take 5 minus 6. So I'll put those results right here. So 4 minus 5. 6 minus 6, eliminated. 12 minus 4, 8y. 18 minus 2, 16z. 36 minus 18 is 18, and that's number 7. Next one, 5 and 6. 6 minus 6, eliminated. 4 minus 15, negative 11y. 2 minus 15, negative 13z, and 18 minus 42, yeah, negative 24, and that's number 8. So what we have to do now is we have to take these two and pretend like we're in grade 10 and do a mini version of what we just pulled off. So I am going to times this one by 11 to make 88, and times this one by 8 to make 88, which for me is better than multiplying by 16 and 13. So that's what I'm going to pull off. So 88y plus 176z equals 198, and then times 8, so negative 88y, 13 times 8, 52, 104 z, and 24 times 8, negative 24 times 8, so 2 carry the 3, 192. Well, now I have to do whatever it is that I have to do to eliminate this, because that's what I have made the same. And if I add those, so if I take equation 9 and add it to equation 10, I will eliminate those. It means that I have to add these, which is 72z, and I have to add these, which is 6. So now I can get the z by itself. And remember, you're in grade 12, these numbers don't have to be pretty. So z alone is equal to 6 over 72, which is reducible, so it's 1 over 12. So this is one of my coordinates of the point of intersection. So now what I have to do is I have to find the other two coordinates, the y coordinate and the x coordinate. So I'm going to sub this into number 7. So I either have a choice of number 7 or number 8, or slightly worse, 9 or 10. I'm going to sub z equals 1 over 12 into number 7, because it's the non-negative one. That will turn my z into a number and leave only a y. So if I go any higher than that, I've got too many letters. I'll have to do that in a minute. So 8y plus 16 times 1 over 12 equals 18. So 8y plus 16 over 12 is 4 over 3 equals 18. 8y is equal to 18 minus 4 over 3. $36, 18 times 3, 54, 4. So that's 50 over 3. Use your ABC button if that messed with you. Get the y by itself. I've got y equals 50 over 3 divided by 8, so times 1 over 8. So that's 50 over 24 divided by 2 divided by 2. So there is my y coordinate. And now I have to reach way back to the beginning. I can either pick 1, 2, 3, 4, 5, or 6. Not sure why I'd ever pick these to find x. So I've got the y and I've got the z. I need to find x. So I'm going to pick number 1. And the reason I'm going to pick number 1 is because the x doesn't have any coefficient, which means I don't have to divide in the end. So I'm just going to write it here, then haul it downstairs. And because this is all over the map and there's so many steps, you have to tell me what you're doing. So I'm going to sub z is equal to 1 over 12 and y is equal to 25 over 12 into, and I chose 1. So x plus 2 times 25 over 12 plus 3 times 1 over 12 equals 6. Plus 20, I'm not gonna skip steps, so 50 over 12, 2 times 25, 1 times 12, plus 3 over 12, 3 times 1, 1 times 12. And I'm going to leave them unreduced. But I am going to fix this 6. And 6 is 72 over 12. So 72 minus 50 is, oh my gosh. 22. 22 minus 3 is 19 over 12, and I don't need to reduce. So I'm pretending like I don't have a calculator. So we have determined, based on the triple scalar product, that we're expecting a point of intersection, and then I came out with a digit for z, a digit for y, and a digit for x, as opposed to needing any parameters. So that means I can answer this with an overall therefore statement with therefore the planes meet at the point over 12. 19 over 12, 25 over 12, and 1 over 12. And no, you can't mess with this. That is where they meet. All right, so now let's go back and look at F, now that we have a process for this. And here's my example. So there's my picture. Sorry, the three planes are non-parallel, but they still do not share any points. The lines of intersection between each of the sets of two planes are parallel. So basically, let's see if I can do this. You've got this triangular thing happening. Does not have to be isosceles, does not have to be equilateral. It just has to be a triangle. And this line here, where those two planes meet, and this line here, where those two planes meet, and this line here, where those two planes meet, are all parallel to each other. So that means there is no meeting place for all three. So let's get that out of there. Whoa! When you take a look at these normals, you will find that there is no pattern. And what do you do when there is no pattern? You do the triple scalar product. Every single time. Because I'm not going to tell you what result to expect in the middle of a test. So I'm going to always do the same thing. I'm going to do N1 cross N2. So 1, 2, 3, 1, 2, 3. Isn't that pretty? Same thing as before. 2, negative 1, 4, 2, negative 1, 4, gone, gone. Down to the right, minus down to the left. down to the right, minus down to the left, down to the right, minus down to the left. So there's the result of the cross product. And I have to dot that with the normal that I skipped over, which is this one. So 11 times 3 plus 2 times negative 14 plus negative 5 times 1. That's 0. Now, based on the fact that I did my example F in the pictures before I did E, if we check F, if your triple scalar product ends up as a non-zero answer, that means you have a point of intersection. So I can guarantee you with this 0 answer, that we do not have a point of intersection. But that doesn't mean we don't have a line of intersection. So the problem is we have to go through what we just did, and I will be able to explain this to you. So get rid of it for the time being. Get rid of it for the time being. Actually, I'm going to leave it there. I'm not going to fight. So I'm about to dig out my blue pen again and write down my 3 planes the same as I did before. So x plus 2y plus 3z is equal to 4. 2x minus 1y plus 4z is equal to 7. So I made it consistent. And last of all, 3x minus 14y plus z is equal to negative 48. So we have to do what we did in the last question. We have to eliminate the same letter twice. And you can go for whatever you want, but I'm going to try to consistently use the x, because then I get into a system of doing the same thing over and over again, regardless of the numbers. So I'm going to times this by 6 to make a 6, this by 3 to make a 6, and this by 2. So that gives me 6x plus 12y plus 18z equals 24. And 6x minus 3y plus 12z equals 21. And finally, times 2, 6x minus 28y plus 2z equals negative 96. And just like before, I'm going to do 4 minus 5 because they're stacked, and 5 minus 6 because they're stacked. So that way my I doesn't have to jump over anything. So 6x minus 6x, gone, eliminated. 12y minus negative 3y is 15y. 18z minus 12z is positive 6z. And on the other side, 24 minus 21 is 3. Then I get to do it with 5 and 6. So 6y minus 6y is gone. Negative 3, subtract negative 28 is 25y. 12 minus 2 is 10z equals 21 minus negative 96 is 117. So you do get some pretty nasty numbers. That doesn't mean you're doing it wrong. That just means there's nasty numbers. So I'm going to times this one by 4 to get a 60. Oh, that won't work. Shoot. Yikes. Times this one by 10 and this one by 6. So you'll see that when I did this one, I eliminated the x's, and then I eliminated the y's. It really doesn't matter. This time I am eliminating the x's, then eliminating the z's, because my numbers are kinder by not very much. So 150y plus 60z equals 30. And times 6, 150y times 6, 60z equals 702. So now, just like before, I can take number 9 and number 10, and I can subtract them and eliminate the z's. Now, I hope you see a problem here. 150 minus 150 is 0. I intended to do 60z minus 60z, so I'm not going to write that down and eliminate it. And I've got 30 minus 702, which is negative 672. So when I go to get the y by itself, I get something that is illegal, because I'm doing negative 672 divided by 0, and you should know that you can't divide by 0. So this is impossible. You don't have to divide by 0 to prove to yourself that it's impossible. It just is. And that means that we get to stop and say there's no intersection, which, because I told you which situation it was, you knew going in. But in a regular, like, test-like situation, you don't know going in what situation you have. So you find the triple scalar product, you find out that you don't have a point of intersection, you gear through it, and you find that you end up with something impossible. Now back to the circle, we did end up, because of this situation, because of the layout of these planes, we did end up with 0t equals 0, which when we did the intersection of two planes was something that was impossible, so it couldn't happen. So same deal, consistency. All right, so I am going to stop there because, yep, I'm under 30 minutes, and I will come back and take a look at the last two situations. So the end for now